Daniel. Quiet. Yes. All right. So, and I gave these to you, I think, didn't I? And all right. So, for this first part, we've got this function. This is the graph of f. It consists of 4 line segments, and then it gives you the function g, which is this integral defined function. So, whenever we are doing this part here, let me give myself some room to write. All right, so if you are finding g of 0, you are plugging in 0 for the x in both of these functions. So that's going to be 2 times 0 plus the integral from -2 to 0 of f of t dt. Okay, so we're plugging in 0 for the x in this equation. All right, so 2 times 0, of course, is just 0. What does it mean to find whenever we've got the integral from 0 to t of f of t? Integral, though, means area under the curve. So from -2 over here to 0, we're just going to find the area of that part right there, which is going to be 3, because you got a rectangle here that's 2, that part's 1.
So when you're finding the area, did you do a root sum, or how did you just count?
You're just finding the area of that triangle in that box.
Can you show me how did you find the area? How did you
The length of this is 2, the side is 1, 2 times 1 is 2.
Oh.
Right here you got a triangle,
Yeah.
height is 1, base is 2, 1/2 times 1 times 2 gives you 1. So if you put those together, you'll get 3.
Yeah.
So just like triangles and rectangles there.
That's not a triangle. No.
All right. So we get 3, and so we get 3 for g of 0.
So do we have to show any work to go from the interval of -2 to 0 f t
To go, I don't think so. I don't think you would have to on that.
Then we got to do g of negative 5. So that's done with g0.
Yep. Same thing for g of -5. So 2 times -5 plus the integral from -2 to -5 of f of t dt. What's the problem with that integral right there?
It's the negative is on top. -5 is on top. Yeah, the lower
Right.
one is -5.
Right. So we need to switch them. When we switch them, what do we do? Make it negative.
Negative. Oh, so you switch the sign.
Yeah. And so this is just the area under the curve from -5 to -2. So from -5 up to -2, we've got this area here, which is below the x-axis. It would be 1/2 times 2 times 4, which is just going to give us 4. So this piece right here is -4. But then we'd also have this little triangle right here, which is going to have an area of 1/2 times 1 times 2. Okay, so we got -4 and +1 there, which is going to give us -3. So we're going to have -10 minus -3. -10 plus 3, which will give us -7 for our g of -5.
I may have done that one right. How many points is this worth, too?
Probably.
I think those numbers were actually used on the test.
sure I'm.
Exactly the same as one of the questions on this test.
Did I give you the same question?
No,
If so, I'm quitting right
It was
now.
a very different. Very different.
I don't
No.
think the next question, but the first
No,
question.
it was similar. It was a little more simple. It doesn't have the 2x out front,
Oh, yeah.
and it tells you the areas instead of you having to like actually do the formulas.
So, it says FT, but the graph, is that not FT?
T is just what they're using as like a dummy variable.
So, how can you know it?
So the derivative
So
of G,
this
that
is-
graph of F,
This actually never tells you what the variable is for f. It just says the graph of f. So f could be of any variable. It could be of x, it could be of t, it could be of whatever you want.
wait,
So-
they're not linked. So like if you do G
Yes.
prime of X,
They are.
is it
Yes, they
not
are.
that?
So here we're going to have to find g prime. And when we take the derivative here, when we take that derivative g prime of x, the derivative of the 2x is just 2. And then when we take the derivative of this integral function, derivative of integrals just cancel each other out, but you'll take that x and plug it in here. So that, and this needs to be x here and this can't be, because when we're plugging in 0 for our x here, we would not want to be plugging it into the function. We're plugging it into the integral there, because if we plugged it into the function, it'd be different. So it'll be plus f of x. So if we want, for each g double prime, so this is the answer for the first part. This is g prime of x in terms of f of x. So this is the answer for the first part. Then it says for each g double prime of 4 and g double prime of -2, find the value or state that it does not exist. So what would g double prime of x be?
Big
F double prime.
F prime of x. Because we're taking the derivative here. So when we take the derivative of 2 is just 0, derivative of f would be f prime. So, if I'm looking at g double prime of 4, first of all, tell me, what we need the slope of f at 4. So, if I go up here to the graph, at 4, or right here, it's going to be whatever the slope is between these points, which I think is -1. But if you are not sure, just do slope formula for those points there. So we got 2, 3, and 8. 2, 3, and 8, -3. So sometimes it may be something where it's a little harder to see. Y2
minus y1.
over,
X2 minus x there.
good, -6 over 6, which will give you -1. You don't necessarily have to show that work. But especially if it's something where the slope's not as easy to tell what it is, you might want to. So that is our slope there. What about g double prime of -2?
Jack, why don't you steal the page?
Are you sure?
It's 0. How's it not?
-2's right here.
Write it down. I'm just kidding.
-1/2. Actually, it's just
Oh my God, Jack, make up your mind.
it's nothing.
All right, so I can't tell what the slope is because I have a slope of 2 on one side, but I have a slope of -1/2 on the other.
Is that one of those points?
What do we call those? Cusp. All right, so this would not, does not exist. Because, and make sure here you say f of x has a cusp at x equals -2. Or you can say sharp turn in the graph. There. Yes. Yes. It's not asking us for F double prime. It's asking us for G double prime. So G double prime is the same as F prime, so it is just going to be the slope of this graph. And it's important to show that right there where you're showing G double prime equals F prime of X. So make sure whenever you're doing a problem like this that you say that G double prime equals F prime. Yes. I would, D&E is something they're going to take on the exam. So if you, they don't give a specific list of abbreviations that they will accept and not accept because that could go on forever. But D&E is standard enough. I think they will take it. I generally tell you to write everything out because you don't want to risk it, but I feel pretty certain they'll take it if you put D&E.
So find the value or state that it does not exist. So we just put G double prime of negative 2 equals D&E. Because it doesn't say like justify, it just says just say that it doesn't exist.
I would put that because there, just to be safe. I think the way the problem is worded, it might be okay to leave off the justification. But just to be safe, I would still put it. Because at the beginning of all of these problems, they will tell you that you must show your work and justify your answer, even if it doesn't tell you to. Usually they'll tell you to, but I would put it there just to be safe. Okay. All right, so on what intervals, if any, is the graph of G concave down? Okay, so it's not asking us about F.
So if it's decreasing,
F
it's decreasing, then
does not have concavity. But we know that we've already stated that G double prime of X equals F prime of X. So if F is decreasing, then F prime is going to be negative, which would cause G double prime to be negative, which means we're concave down. So, all right, so we know if G double prime of X is less than, let me write this. If G double prime of X is less than 0, G is concave down, right? But we don't have the graph of G, so we can't answer this problem from the graph of G. So G double prime is equal to F prime. So it would also be true that if F prime of X is less than 0, then if F prime of X is less than 0, then G of X would be concave down. And so we, again, can't answer this from F prime because we don't have the graph of F prime.
But we do.
We have the graph of F.
Which gives us the graph of F prime.
Right, so if F is decreasing, then F prime will be negative. So what we would look here from -2 to 0 and 2 to 8, we would say G is concave down for -2 to 0 and 2 to 8 because it's important here. F of X. You must answer this from F of X because that's what you have the graph of. You can't talk about G double prime and you can't talk about F prime until you talk about what you see happening on F. So it's because F of X is decreasing. which means that f prime of x, and I'm going to put which equals g double prime of x is less than 0. I think you could leave off that very last part, the part where I said which means that f prime of x equals g double prime of x is less than 0, as long as you have stated either in part A or part B that g double prime of x equals f prime of x. So that has to be stated somewhere. Part A, if you've already stated it in part A, you don't have to restate it, or part B, you don't have to state it in part C. Okay. All right, so the last part tells us that h of x equals g of x cubed plus 1. So that means I've got to plug x cubed plus 1 into the g function, which is this function up here that has the integral in it. So that's going to look like this. 2 times, instead of the x, we put x cubed plus 1. It's plus, isn't it? Plus the integral from,
how did you know it was
because we're plugging it into this function right here. So everywhere we see an x right here, we are going to replace that with a x cubed plus 1. So it's the integral from -2. The x is x cubed plus 1 here. Over here you have a t, f of t, dt. Do not replace it with an x. That's your dummy variable that you're using there. Okay. Now, you can't figure out h of x, but it doesn't ask you for h of x. It asks you for h prime of x. So, if we're taking the derivative of this, okay, right here, I actually would probably do this. This is 2x cubed plus 2, right there, if we distribute that 2. So the derivative would be 6x squared. Derivative of 2 is just 0. What do we get when we take the derivative of the integral? Okay, so we plug that in for t. We get rid of the integral. So we get f of x cubed plus 1 times the derivative of x cubed plus 1, 3x squared.
So when you're integrating the integral after you plug in the dummy variable, what do you do out in front?
So we are taking the derivative of this, and when derivatives and integrals are inverses of each other. So when we take the derivative of the integral, they cancel. We just have to take this upper limit and plug it in here, which is what we did here. But we must multiply by the derivative of that upper limit.
Oh, yeah. But what about integrating? Is that integrating?
No, we're taking the derivative.
Oh, yeah.
We're not actually integrating this. We're taking the derivative of the integral, which just kind of cancels it out. There.
After this, can we do like a simple integrating problem?
They would not ask you to integrate this because it's not something that you could do. Yeah. If it's U substitution, you may have to do something.
doesn't match up. Pull it out.
Yeah. Okay. And they asked for 1, so we're going to plug in 1. 6 times 1 squared plus f of 1 cubed plus 1 times 3 times 1 squared. So this is going to be 6 plus 3 times f of 2. You can just read the f of 2 from the graph. Scroll up here and see real quick. At 2, you have a y coordinate of 3. So it's just going to be 3 there. And so that's 6 plus 9, which is going to give you 15. Ethan? Yes.
Could you not have just gone through h x by having g prime of x cubed plus 1 times 3x?
Oh yeah, there was a
All right, I cannot hear Eli's question. Be quiet. Say that again.
Find h prime of x by getting g prime of x cubed plus 1 times 3x squared.
Yes, you could actually do that. So if you do it this way, that's a good... So Eli did this differently. He did not plug it in immediately anyway. He took h prime of x and he said the derivative of g, which is g prime of x cubed plus 1, times the derivative of the inside, which is 3x squared. And this is actually easier, isn't it? Because g prime equals f. So when we do it this way, it'd be g prime of 1 cubed plus 1 times 3 times 1 squared. G prime of 2 times 3. And let's not get this right answer, that is it.
Then you get 2 plus f of 2 in parentheses. Yeah, because g prime equals...
Oh, that's right. That's right. G prime is 2 plus f of 2. Okay, there we go. Times 3. Yes.
Will that work with like?
Yeah, that works. Yeah, that'll work. I was replacing g prime with just f, but up here, g prime of x equals 2 plus f of x. So you could just plug, whenever you're finding g prime of 2, you would just plug it in here, 2 plus f of 2. Yeah. They're similar in difficulty, so either one would be fine. Okay. Questions? All right. All right. Solutions for the other two are on Canvas, so you can look at those. I'll be here in the morning. If you guys have questions, you can come see me during lunch. If you have. So we have already seen differential equations in a way whenever we see things written like dy over dx equals 3x plus 2. That is a differential equation. It is a super simple differential equation, as we'll see when we start solving them. But it is a differential equation. And then this is a second derivative, which we have not really worked with, but that is also a differential equation there. So what we're going to look at first is taking all of these words and seeing which one of these could represent that relationship. Probably one of the hardest parts about this is being able to understand how the situation applies to the equation that you are looking at. So one thing that's going to be important to know is the phrase directly proportional, because we're going to see that a lot. And direct proportionality comes in like Math 1, although I don't usually call it that or really work with it that much. It just means if two quantities A and B are directly proportional, then A equals K times B, where K is a constant. One thing I sometimes will tell people to think about for direct proportionality is it's similar to your wages. That K is like your wages. So if your wages are going to be directly your income is directly proportional to the amount of time that you work, right? Assuming you're paid hourly, right? So if you work for 10 hours at, $10 an hour, let's say 15 hours, at $10 an hour, you'll make $150, right? This K right here is like how much you're paid per hour. That's your hourly wage. Now, it can be represented in a lot of different situations, but basically it just means that we can find something by taking a number and multiplying it by whatever value. With wages, it would be your hourly wage times your time in that case. So let's look at this problem. The rate at which a quantity M of a certain radioactive substance decays is proportional to the amount of substance present at a given time. Which of the following is a differential equation that could describe this relationship? Okay, so let's think about it. Rate at which a quantity M of a certain radioactive substance. So a rate of a substance is not going to be M, but that's going to be our dm dt, because it's not the amount of the quantity, but the rate at which that quantity is changing. So that's our our rate over time. It is proportional, so it's going to equal, and proportional is the same as directly proportional, so it's going to equal, I'm going to put a K right here, it's some number, to the amount of substance present. What variable represents the amount of substance present? M. Because M is our quantity there. So K can be any number, so B would be the answer. Why is it not D instead of B? This is decay, so it's going to be negative. Okay?
Would any decimal of any positive or negativity be decay?
It would have to. It's more to do with whether or not that number is negative or not. So, so it could be like -7.
So 0.7 would be growth.
Yes, positive 0.7 would be growth. Yeah. Because it's not exponential growth, it is, but you're looking at the derivative, so it's positive or negative is what you're going to be looking at here. Okay. Okay, it's so much reading.
I'm so excited.
Yeah, Thomas likes this. Some of you are just going to quit. You see a problem that looks like this, you're like, oh. This is why I took this class. I didn't have to do stuff like this.
Actually, it might be B.
All right. So the population of a certain series of species of insect is given by a differentiable function P, where P of T is the number of insects in the population in millions at time T, where T is measured in days. When the environmental conditions are right, the population increases with respect to time at a rate that is directly proportional to the population. Starting August 15th, the conditions were favorable and the population began increasing. On August 20th, 5 days later, there were an estimated 10 million insects and the population was increasing at a rate of 2 million insects per day. Which of the following is a differential equation that models that situation?
Now I have to annotate my math.
So, yeah. So, A is not even a differential equation. So, yeah. And it's not a differential equation because it doesn't have the dp dt. So let's look at the part where it tells us the environmental conditions are right. The population increases with respect to time at a rate, so that's our dp dt. The rate is directly proportional to the population. So directly proportional to the population, which is our P, not our T. So what,
C or D?
I can mark out B because that B has the T there. So,
I think it's C.
and it's increase. Well, these are both increasing, I think.
Yeah, but it's the rate.
All right, so starting August 15th, the conditions were favorable, and the population began increasing. 5 days later, there was an estimated 10 million insects,
The rate is 2 million.
and the population was increasing at a rate of 2 million insects per day. Was the font? Let's see.
Yes, 2 times is 1 million.
Yes, so you would be.
I already hate this key.
All right, let's see. 5 days. I'm gonna have to revert to my answers. I'm afraid. There was an estimated 10 million insects in the population.
5
It
days
was increasing at a rate.
causing 10. Increasing it to.
I think it's 2 million insects per day. 10 by 5.
2 times 5. So if it's 5p, then that's 5 times 10 million. 1/5 times.
Right,
10
you're right.
Is 2 million.
All right, Thomas is right here because so I know that if it's 1/5 p, then dp dt right here 1/5 times. We're talking about the population here is 10 million. P is population, right? Which is
It is pushing p. Insects are inherently pushing.
and so 1/5 times 10 will give us 2 million. That is your rate, right? So your rate at this time should be 2 million per day, which if you plug in 10 to this, you get 2 million per day. But if you plug in 10 to the second equation, you will get 50 million, which is not the time. So it should be C, I think. Let me double check the answers because I told you I get a little mixed up on these.
No, I swear it's
Come on.
C.
C, we're right. Okay. All right. Okay, here's another one. All right, scientists is studying a relationship of two quantities, S and T, in an experiment. The scientist finds that under certain conditions, as the quantity of S increases, the quantity of T decreases. After taking measurements, the scientist determines that the rate of change of the quantity of S with respect to the quantity of T is inversely proportional to the natural logarithm of the quantity of T. Which of the following is a differentiable equation that could describe this relationship? Inversely proportional.
C. Well, it's not A and it's not B.
So if you have two things that are inversely proportional, it's not going to be K times that amount, but K divided by whatever that amount is.
So it's not B or A.
So let's read this. So the rate of change of the quantity of S. So rate of change of the quantity of S. What would that be? ds over dt. So that tells me it's probably not A and it's probably not D. With respect to the quantity, oh, actually, I put the little t out of habit. It's not with respect to time. What's it with respect to? Quantity of t. So that little t right there really shouldn't be a little t. It should be a big T. Doesn't help us over here though. Is inversely proportional. So this time we're going to we'll have K over the natural log of the quantity of T. Natural log of T, which C.
Could you also just break it down that S is on top on the left and T is on the bottom on the right? And they're inversely proportional.
Does that not work for?
Yes.
What
What?
he said, where S is over T, does that work for most inverse proportional?
The T right here doesn't have anything to do with it, but over here, you yeah.
You wouldn't have a T across something like this. This one. It's the K have to be on top.
K would have to be on top. So that would rule out B. We ruled out A because of the S here. We ruled out D because of this, because it's DTDS. So that would give us what we have here.
So when it's like inversely proportional, will it always be K over those?
Yes. Unless you end up with like K over, for some reason, 1 over X. And then you got to do dividing fractions easy as pi flip second multiply. But I don't think they'll do that to you. I hope not. Okay. A jogger runs along a straight track. The jogger's position is given by the function P of T, where T is measured in minutes since the start of the run. During the first minute of the run, the jogger's acceleration is proportional to the square root of the time since the start of the run. Which of the following is a differential equation that describes the relationship where K is a positive constant?
So it would have to be squared because of acceleration.
Okay, because it says P is our distance, so dP dt is velocity, so that's not what we're talking about. So you guys are correct. We can narrow it down to C and D, because it should be a second derivative. So is proportional to square root of the time, so that is going to be C.
And that's just in the problem.
Yeah, this is just interpreting. Yeah. Because it is dP dt, and this is the jogger's acceleration, which is going to be the second derivative of P. Because if we just take the derivative of P, it would be our velocity, and acceleration will be second derivative. Yes?
So all it's going to say is that K is the positive constant. So the other variable that you're looking for is just put on the test. So I think that's what you're going.
Yes. Okay. To me, these are doable whenever they're multiple choice. A little tougher if they're not multiple choice to come up with. But we'll probably just see a multiple choice. So the weight of a population of yeast is given by a differentiable equation W, where W of T is measured in grams and T is measured in hours. The weight of the yeast population increases with respect to T at a rate that is directly proportional to the weight. It's weird. At time T equals 10 hours, the weight of the yeast is 200 grams and is increasing at a rate of 5 grams per hour. Which of the following is a differential equation that models the situation? Okay, it's becoming true that all of these end up being C, isn't it? I think it's going to be the case here. So weight, first one wasn't. So the weight of the yeast population increases with respect to T at a rate, so that's your dW dt. It is directly proportional, there's your K, to the weight. So that's W. So that rules out B, A, we already mark out because it's not a differential equation. And so just like the other one that we were doing a minute ago that gave us information, if we have 200 grams, the rate is 5. So just plug in 200 right here, and 200 divided by 40 is 5. But if we plug in 200 here, a half times 200 would give us 100, which is not right. So it's going to be C. All right, one more to look at. If the pressure P applied to a gas is increased while the gas is held at a constant temperature, then the volume of the gas will decrease. The rate of change of the volume of gas with respect to the pressure is proportional to the reciprocal of the square of the pressure, which of the following is the differential equation. So, rate of change of the volume of gas with respect to pressure. So that's dV dP. I guess they're using a capital P, actually.
How do we determine if it's positive?
Okay. Is proportional to, so equals K times, the reciprocal of the square of the pressure. Reciprocal is going to mean we're doing 1 over P squared. So, it is once again. Actually, what's different between? Okay. Alright, so it tells us that volume of the gas will decrease. So K, let's see, make sure. Increase.
V decreases, then V should be on the top, which it is.
I think it might.
This one's wrong.
Is it positive? Let me just check the answer before I. Okay. All right. Okay. Yes. So because we have that decrease, we'll have the negative constant. Because the volume of the gas will decrease. Yeah. Okay. So do you guys get the idea for this? They're very wordy, but if you read through them carefully and understand the rate and how to write that, and then directly proportional means K times something, inversely is going to be K over something, I think you can probably. Alright, so. Oh, why is this not working? Alright, let's just do this. We can. Jack, put it away. Put it away. At least you can make a paper airplane though. My Math 1 kids sometimes. I bet it might be in here too, but I haven't done it lately because of all the COVID stuff. But I used to have them make a paper airplane, like put their answer on a piece of paper, make a paper airplane, and fly it, and everybody had to pick up somebody else's answer. But I realized there was only like 3 people in the class that could make a paper airplane. I had a couple kids just ball their paper up and throw it.
That's what
I let one year I actually let one kid just like come up and use the document camera to show kids how to make a paper airplane. I feel like that was a skill they needed in life.
That's a necessary life skill.
Yeah.
one that I learned.
Let's see. Okay. All right. Let's look at this problem so you guys will know what to do. All right. So if I've got y equals 2 sine of 4x. Okay, so I'm checking to see if this is a solution.
So we should reset.
All right. So this differential equation here has a second derivative and a first derivative. So I need to take the first derivative of this. Thankfully, they'll usually give you something that's fairly easy to take the derivative of. So derivative of sine is cosine. Integral is negative. You'll have 4x. You got to multiply by the derivative of 4, which gives you an 8 out here. Second derivative is going to be, derivative of cosine is negative sign. So I'm going to have sine of 4x. We'll have to multiply by 4, so we'll get a negative 32 out here. So we're going to plug these in and see if it's true. So negative 32 sine of 4x minus 6 times 8 cosine of 4x plus 8 times 2 sine of 4x. So right here, all this is going to be, you've got negative 32 sine of 4x minus 48 cosine of 4x plus 16 sine of 4x. You could put these two together, which is going to give you negative 16 sine of 4x minus 48 cosine of 4x. So stuff did not cancel out to give you 0 there. So it does not look like that would be an answer.
That's like a 1.
Okay? All right. If we're doing the same thing with the second one, y is 3e to the 2x. Y prime, the derivative of e to the 2x is e to the 2x, but multiply by the derivative of 2, which is going to give you 6. And y double prime would be
e to the 2x times the variable out in front.
yep, 12e to the 2x.
You can hear my brain working.
Them 2 brain cells are putting it over.
Daniel.
That's what I was saying.
Okay. All right. So second derivative would be 12e to the 2x minus 6 times 6e to the 2x plus 8 times 3e to the 2x. So you got 12e to the 2x minus 36e to the 2x plus 24e to the 2x. And if we put 12 and 24 together, we get 36. And then we're going to have to subtract 36, so all of this equals 0. So 2 is an answer choice.
You just assume the next one is right.
I bet it's 2 and 3.
Yeah, it's still
Because they want you to work out all of
I don't know if it's going to be or not because you got the 6 and the 8. I'm not sure that's going to always be standard. I'm not sure. We're going to have to work it out.
Just a monotonous
monotone.
So we got that same pattern happening here.
So it should check out.
So let's see what happens when we do this. We'll have 16ce to the 4x minus 6 times 4ce to the 4x plus 8ce to the 4x. So 16 minus 24 plus 8, it would have all that ce to the 4x, but I'm not writing it because I've spent long enough on this problem. And that is going to be 24 minus 24, which is going to be 0 also. So 2 and 3 would be correct. Let's do 2 together too. D. Yes, as in dog. So this is saying for what value of k, if any, will this be a solution to the differential equation? So this differential equation here has a y double prime in it. So we have to find that second derivative. So y is ke to the negative 2x plus 4 cosine of 3x. Y prime, e to the negative 2x is going to be e to the negative 2x. But you'll have to multiply out here by the negative 2. So you'll have negative 2 k e to the negative 2x. Derivative of cosine is negative sine. And you'll have to do the chain rule here. You'll get a 12 cosine of 3. Oh, sorry, that should be sine. Sine 3x. Okay, so there's our first derivative. Second derivative is going to be 4 k e to the negative 2x minus 36 cosine of 3x. So we are taking our y double prime and our y, and we're plugging that into this equation, which is hopefully going to give us something we can solve for k. Or if we can't, d would be our answer. So we'd have 4 k e to the negative 2x minus 36 cosine of 3x. That's our second derivative. Plus 9 times our first derivative, k e to the negative 2x, plus 4 cosine of 3x. And this is supposed to, yeah. They might give it to you, maybe. Possibly. They might give you a little bit easier equation, but it could be there. So you got 4 k e to the negative 2x minus 36 cosine of 3x plus 9 k e to the negative 2x plus 36 cosine of 3x equals 26 e to the negative 2x. So the negative 36 and the positive 36 are going to cancel. And we can combine the 4k e to the negative 2x and the 9k e to the negative 2x. So we are going to get there 13k e to the negative 2x equals 26 e to the negative 2x. So this part right here is the same. Alright, so we really just need 13k to equal 26, in which case, if 13k equals 26, if we divide both sides there, we'll get 2. So k should be 2, which is A.
So once you got the e's to equal each other, you don't have to worry about.
Right, because you know those parts are the same, so you just have to get the unknown parts there to equal. You could think of like dividing off e to the negative 2x, although we don't really love to divide things off with x's in them, but they could just kind of cancel each other out.
Where did we spawn this 13?
The 4 plus the 9. Okay, so the rest of these problems are of a similar nature, so hopefully you can figure out what to do on those. If you have any questions, we got about 12 minutes, so please do your work. Also, do not forget FRQ will be tomorrow, and Chandler and Margaret are going to come do their tests for me. They're in third period, right? I've graded multiple choice, so I can tell you. I'm not gonna let you see it because I don't want it to leak to the ones who haven't. But I can tell you how many you got right on multiple choice if you want to know. See, Emerson, there is yours. That multiple choice is pretty decent. Yeah. Over half is good. So, anybody else want to know theirs? Let's see. Eli. Here's go. Here's yours.
Okay,
Pretty good.
Logan wants to see this.
Logan.
And he doesn't want to get it.
Okay. Logan, I just announced yours. 13 out of 18. It was looking a little blank on the FRQ, so.